Hi there, I'm Mr. Orr, and today we are looking at another aspect of section 7.3 in the geometry book. This is, what I want to do is look at some reflections across the axes and across a couple of particularly important lines on the graph. And we're going to develop some rules for how these work. So let's start with a simple point. And I'm going to make that point at 2, 3. Okay, so 2, 3, and we'll call that point A. Now, if I reflect that point across the y-axis, then I was 2 out this way, so I'm going to go 2 this way. Straight reflection across the y-axis. At this point, we will call a prime. That prime signifying that it is a reflection of the original point. And this new point is -2, 3. Now, if this then was x, comma, y, then this one is -x, y. So we're going to establish the rule here that if we reflect a point across the y-axis, so a reflection, let's see, a reflection across the y-axis, x, comma, y becomes -x, y. Okay? So there's rule number 1. Now, let's get rid of this reflection and try a second one. Let's reflect this across the x-axis. So if we're up 3, we're going to be down 3. Straight reflection again across the axis. And if that was 2, 3, this is now to -3. And if we call this then point A prime, we have gone from xy to x -y, or opposite y. All right, so number 2 is going to be a reflection across let's fix that, a reflection across the x-axis, and that is x, y, comma, y, becomes x opposite y. All right? The next one we're going to look at, I'm going to take this point away for the time being, and we're going to look at a reflection across the line y equals x. So if I draw this line here, and remember y equals x means that the slope is 1 and the y-intercept is 0. So there's my line. That's a very important line in graphing, which will come back to you in future years in Algebra 2 and Pre-Calc as well. This line y equals x means y equals 1x plus 0. So it goes through the origin, and it goes up 1 over 1 for the slope. All right, now let's take a point that we want to reflect. And I'm going to go to here, and we'll call that, let's see, that is 1, 3. And its reflection is here, because I want to make a perpendicular, and its reflection is right here. And that would be 3, comma, 1. So 1, 3 went to 3, 1, and what that means is x, y went to y, x. So the x and y reverse positions. So a reflection across the line y equals x went from xy to yx. All right, rule number 3. Rule number 4, we're going to establish by taking that line away and making yet another line, and this is going to be the line y equals -x. So that's this line here. And what that means is, again, the origin is, the point of intersection with the y-axis is the origin, and the slope is -1 up 1. So we have a slope of -1. All right, let's take a point out here, like this point, and go to this point. Actually, yeah, that's all right. Let's try that. All right, so we have a point at -1, 3. And now we are at negative 3, comma, 1. So x, y, they switched positions, and they also switched signs. So negative 1 switched places and became positive 1, positive 3 switched places and became negative 3. So the rule should be a reflection across y equals opposite x or negative x. We get xy going to negative y, negative x. So again, they switch places, so y and x switch places, and they switch signs. So it's opposite y, opposite x. Now, those are the 4 that we're going to be using quite a bit as we do some reflections, rotations, and translations. And what we're going to do, we're going to develop some additional rules for rotations. 90 degrees clockwise, 90 degrees counterclockwise, etc. And then we're going to put these together. On the graph, we're going to put together a slide, a flip, and a turn. And we will be doing that a couple of sections from now, but in the meantime, the next section we're going to take a look at is 7.4, I believe, which has to do with translations and vectors. I'll be back. Thank you.